In Tape 1, we reviewed the types of fire sprinkler systems, their basic function, and application. In this segment, we'll explore the factors that should be considered when selecting an automatic sprinkler system. We'll also get into the subject of hazard classification, those criteria that determine how the fire sprinkler system will be designed and applied. When considering the installation of an automatic fire sprinkler system, the first step is to make certain you understand the objectives or reason that the system is being installed. Is it life safety, code equivalency, or one of the other objectives we discussed in Tape 1? Next, you should consider what type of flexibility must be built into the system to enable it to respond to changes in building layout. For example, how often are partitions and ceiling changes likely to occur? Frequent changes in layout are common in retail establishments. If that's the case, the practical solution is to supply the sprinkler system to individual tenants using a loop from the service corridor. Valves can be provided or installed by the tenant off of the loop to their individual space. Each of these valves should be supervised by the building's fire alarm system. In some instances, the owner may choose to provide the individual water flow detection from each tenant space as a service. This too affects the capabilities and type of alarm system chosen for the facility. The likelihood of occupancy changes can also affect the water supply requirements and the spacing of the sprinklers. If the building experiences frequent occupancy changes, you may decide to design the system for the greater hazard, in which case, no revisions to the sprinkler system may be needed when the occupancy does change. You should predetermine how the system will be purchased. Will it be a sole source project, or will you put it out for bid? Small, simple projects can often be handled as a sole source with a reputable sprinkler contractor. Large, complex projects should be designed by a competent fire protection engineer. Additional factors that need to be considered up front are the budget for the project and the qualifications and past project experience the sprinkler contractors have had with the owner or the property. In some cases, it may be appropriate for a large, complex project to sole source the sprinkler installation contract. In that case, the owner will need specifications prepared by a fire protection engineer. The contractor selected should be one who is familiar with the property and has the confidence of the building owner. It is advisable to retain a fire protection engineer to provide construction observation. This is done to verify that the installation is consistent with specifications and code requirements. The use of a fire protection engineer also increases the likelihood that the project will go smoothly and that the owner will be completely satisfied with the installed systems. The fire hazard of any building or facility is determined by the type of combustibles that are present, as well as how many combustibles there are and where they're located. According to NFPA 13, the standard for the installation of sprinkler systems, occupancies or portions of occupancies are classified according to the following factors: quantity and combustibility of contents, expected rates of heat release, total potential for energy release, heights of stockpiles, and presence of flammable and combustible liquids. These classifications are used to design the sprinkler system installation and its water supply. As we discussed in Tape 1, NFPA 13 classifies occupancies as light hazard, ordinary hazard group 1, ordinary hazard group 2, extra hazard group 1, and extra hazard group 2. There are also certain NFPA standards that contain sprinkler system design criteria for fire control or suppression of specific hazards. These are considered special occupancy hazards by NFPA 13. NFPA 13 describes the methods of design, installation, fabrication, calculation, and evaluation of water supplies that should be used for the design of the system in accordance with the specific design criteria of the occupancy standard. In considering the hazards in each category, you should recognize that interior arrangements of any given occupancy could vary considerably. Such changes can affect the fire challenge for an automatic sprinkler system. When considering the hazards present in an occupancy, you should estimate whether the hazard is within the norm or typical arrangement and combustibility of the occupancy type. If there are significant variations, you should consider changing the hazard classification. This requires both experience and good judgment in establishing the proper hazard classification. A fire protection engineer who is experienced in system design and hazard classification can provide the most cost-effective and appropriate approach to the design of the system. The NFPA 13 occupancy hazard classifications take into consideration the fire loading and expected severity of the fire. They do not take into account the likelihood of an ignition and therefore should not be used as a general classification of occupancy hazards. Light hazard occupancies are defined as occupancies or portions of other occupancies where the quantity and/or combustibility of contents is low, and fires with relatively low rates of heat release are expected. The light hazard classification encompasses residential occupancies. Other examples include churches, schools, hospitals, nursing homes, most libraries, museums, offices, restaurant seating areas, theaters, auditorium seating areas, and unused attic spaces. This occupancy hazard is defined as occupancies or portions of other occupancies where the combustibility is low, quantity of combustibles is moderate, stockpiles of combustibles do not exceed 8 feet, and fires with moderate rates of heat release are expected. Examples of ordinary hazards group 1 are automobile parking and showrooms, bakeries, canneries, electronics manufacturing, commercial laundries, and restaurant service areas. This occupancy hazard classification is defined as occupancies or portions of occupancies where quantity and combustibility of contents is moderate to high, stockpiles do not exceed 12 feet, and fires with moderate to high rates of heat release are expected. Ordinary hazards group 2 include distilleries, dry cleaners, horse stables, large stackroom areas of libraries, mercantile, piers and wharves, post offices, stages, wood machining, and wood product assembly. This occupancy hazard is defined as occupancies or portions of other occupancies where the quantity and combustibility of contents are very high. In extra hazard group 1 occupancies, flammable liquids, dust, lint, or other materials present in the area increase the probability of rapidly developing fires with high rates of heat release. Examples of extra hazards group 1 include aircraft hangars not covered by NFPA 409, combustible hydraulic fluid use areas, plywood and particle board manufacturing, sawmills, and upholstering operations using plastic foams. This occupancy is defined in the same way as Group 1, except that it has moderate to substantial amounts of flammable or combustible liquids, or there is extensive shielding of the combustible materials present. Examples of extra hazards Group 2 include asphalt saturating, flammable liquid spraying, flow coating, manufactured homes or modular building assemblies, open oil quenching, plastics processing, solvent cleaning, and varnish and paint dipping. There are also special occupancy hazards that include occupancies or processes whose sprinkler system design criteria for fire control or suppression are contained in NFPA standards other than NFPA 13. Special occupancy hazards include flammable and combustible liquid storage, manufacture and storage of aerosol products, rack storage, rubber tire storage, baled cotton storage, rolled paper storage, protection of records, indoor general storage, and aircraft hangars. As you would expect, the hazard classification of a facility affects a number of factors in automatic sprinkler system design and installation. The fire protection designer must carefully select the appropriate hazard classification to avoid over-design of the sprinkler system, a situation that will lead to excess cost for the building owner. Or conversely, under-design of the system, which could compromise the life safety of the building's occupants or the protection of property. Defining the hazard classification in some occupancies can be subjective. It is important to obtain a confirmation of the classification from the authorities having jurisdiction prior to the preparation of the fire sprinkler system design. The authorities might include the fire department, the municipal building department, and the facility's insurance carrier. There are several key design factors that are affected by the classification of any building or facility. The type of occupancy hazard classification affects the water supply required for operation of the fire sprinkler system. Essential design criteria include density, gallons per minute per square foot, the area of sprinkler operation in square feet, and the duration of the water supply. The relationship between hazard classification and the required water supply are shown in this graphic, which is part of NFPA 13. This table summarizes the minimum water supply requirements for each hazard classification. The actual demand for water will be higher. This is due to the hydraulic imbalance in the system, where a greater flow rate than the minimum is required in order to achieve the minimum flow from each individual sprinkler. The total flow is usually 10% to 20% greater than the product of the minimum density and the operating area. Many regulatory or insuring authorities will require a higher than minimum duration of water supply. This results in a total volume significantly greater than the values shown in the previous table. When the water supply consists of a public water main, the volume is usually not an issue. It can be significant, however, when the water supply must come from a tank or a pond. The layout of the sprinkler piping installation is affected by the hazard classification, including both the protection area and sprinkler head spacing. There are requirements pertaining to the maximum protection area for an individual system and for an individual sprinkler head. This table shows the maximum floor area coverage by the type of hazard. The maximum area of 52,000 square feet for a light or ordinary hazard occupancy will generally accommodate a small, typical office building, either high-rise or low-rise. A single riser will be adequate so long as no floor area exceeds 52,000 square feet. A shopping mall, for example, would generally exceed 52,000 square feet on a floor. If we assume a 300,000 square foot shopping mall, 6 sprinkler risers would be required so that each riser and valve controls no more than 52,000 square feet. The purpose of this requirement is to enhance the reliability of the sprinkler systems in order to limit the consequences of failure of a single valve or riser. A 300,000 square foot extra hazard occupancy, such as a warehouse, would require 8 systems, with each riser and valve controlling no more than 40,000 square feet. The maximum area protected by an individual sprinkler affects the total number of sprinklers required. The NFPA 13 contains requirements for the maximum area protected by an individual sprinkler according to hazard classification and type of construction. Light hazard occupancies for hydraulically calculated sprinkler systems allow a maximum sprinkler spacing of 225 square feet in combustible or non-combustible construction and 168 square feet in combustible obstructed construction. Sprinkler spacing in ordinary hazard occupancies is 130 square feet, regardless of the type of construction. The maximum area that an individual sprinkler can protect in an extra hazard or high-piled storage occupancy is 100 square feet. These values can be increased to 130 square feet for hydraulically designed sprinkler systems when the required density is below 0.25 gallons per minute per square foot. Another factor that determines the total number of sprinklers required and the maximum area that an individual sprinkler can protect are the sprinkler spacing limitations. These are the maximum distance between the sprinklers, either on branch lines or between branch lines. For light and ordinary hazard occupancies, this value is 15 feet, and for extra hazard and high-piled storage occupancies, it is 12 feet. There are some exceptions for extra hazard and high-piled storage occupancies. Where bays are 25 feet wide, a spacing of 12 feet 6 inches is permitted. Where densities of less than 0.25 gallons per minute per square foot are used, a spacing of 15 feet is permitted. Extended coverage and quick response extended coverage type sprinklers may be used only in light hazard occupancies. These sprinklers are described as special sprinklers in NFPA 13 and are required to be installed in accordance with their listing. Similarly, certain extended coverage sprinklers are listed for light hazard and ordinary hazard occupancies, but none are listed for extra hazard occupancies. Steel and copper pipe and fittings may be used in any occupancy classification. Plastic pipe and fittings are required by NFPA 13 to be installed in accordance with their listing. Plastic sprinkler piping is listed only for use in light hazard occupancies. In summary, one of the most significant factors in establishing the automatic sprinkler system design is the occupancy hazard classification. You must take care in selecting the classification so that an effective and efficient sprinkler design can be achieved. Unfortunately, you cannot rely solely on the occupancy categories listed in NFPA 13. You must evaluate the type, quantity, and arrangement of combustibles that will be present in the building or facility to be protected. This will enable you to assess the expected fire severity that the sprinkler system will be designed to combat. For more information on hazard classification, consult NFPA Standard 13, the NFPA Automatic Sprinkler Systems Handbook, or the Factory Mutual Handbook of Industrial Loss Prevention. Also, consider retaining the services of a qualified fire protection engineer who is experienced in hazard evaluation and fire sprinkler system design. The engineer can be a valuable resource in assessing both the fire hazards in your facility as well as identifying the appropriate system design criteria. This is the second tape in the Fire Sprinkler series. In Tape 3, we will focus on water supplies for fire sprinkler systems.